Hey guys, and welcome to another of 4th's Advanced C++ tutorials, where we are taking a look at uh, Lua C++ hybrid programs. um, Last time we took a while to figure out how to make our objects in C++ available for use in Lua through user datas and pointers. Now that we have that, we have the ability to make any of our basic C++ features available in Lua. And we can now expand the Lua language pretty well using those features. We can add things like graphics capabilities, maybe networking capabilities, maybe we want just some sort of make a matrix library, or there's plenty of other applications that you might be using to the Lua to make those applications, and you need to provide those possibilities with your C++ code. Now, the thing is you might also be looking at Lua not in terms of I want to make an application in Lua, but have all my power of C++. You might be looking at the hybrid from the other perspective, which is something we haven't actually used at all yet. The other perspective is, hey, I'm coding in C++ right now, and I want to be able to define certain little things in Lua that will make my program a lot more flexible. I want the flexibility of Lua, but I want to stick mostly to the power of C++, kind of reversed logic. Instead of sticking mostly to the flexibility of Lua and bringing in the power of C++, we're going to reverse it and use the flexibility of Lua here and there while mostly using C++. Now that I think I've repeated that idea enough times, we're going to see what I'm actually talking about. Let's see an example. Let's say you are making a graphical application and you want to have lots of different colors sort of in a palette pre-made, and you are going to have different color palettes that you can be picked from. You want a good way of naming your color palettes and loading them in easily. How could we do that? Well, maybe you start defining this as void load color palette, and you've got your function made, and you're thinking, all right, how is how is loading this color palette going to work? Maybe it'll take a string. I'll use a C++ string because maybe I'm just doing standard library for everything in this application. So I'm going to take a C++ string, and I'm going to or a standard library string, and I'm gonna use the name of that to somehow pair it up with the color palette. Maybe my color palette will be this array here, called maybe I have a struct here for color. That's a good idea, and that's got cars for R, G, and B, and then I have an array of colors, and there's 10 different colors. That's a big number. In the application, maybe you have 10. I'm going to use 4 since it's a small number. You have an array of 4 colors is your color palette. So you want to be able to, geez, I always get other languages mixed up in this process here. Reference. Let's just do color pointer reference. Okay. So we've got some color palette pointer being passed in, and we're going to fill that color palette up with the different colors that are associated with the string. So maybe if I pass in the string basic and a reference to a color palette, which is an array of colors, it will put the black, white, blue, and red are the basic colors for the basic color palette. So the string basic says use that color palette, and then it'll fill that array up with the appropriate colors. So you're thinking, man, I could actually do this so much more easily if I was using Lua, because I would probably, if I was implementing this in Lua, I could use the name of the function and pair that up with the name of the color palette, and then calling the function could return all of the colors using multiple return, and it would be so much easier. than this what I'm having to do here. And then you think maybe I can do something similar in C++. Maybe I can have my functions named after the color palette, but then I still have to have some kind of way where I'm pairing up in a string, since the user is going to be typing in the name of the color palette that they want to use, and I need to convert the string they type in into a function. And you could come up with other solutions, but let's see how you could solve this using Lua config files, and also how much flexibility that'll give you after the fact. So, what we'll do is we'll treat the string, like I said, as a name in Lua. Maybe it'll be the name of a table instead of the name of a string. Let's do that. That way the table can contain other things in the future if we need that kind of flexibility. So, Lua Get Global is what we're going to have to use. And we need to know the Lua state now. So here's a problem. How are we going to get the correct Lua state? We could just make it an argument in the function. So let's start with that. Maybe that'll be a good enough solution. Okay. And then the name that'll come from the string, we'll convert it to a C string, and voila, Lua Get Global. And what that function does, Lua Get Global, is it looks in the global space of variables. So in Lua, there's there's tables, right? And your table can contain variables. And sometimes what you do is you look inside a table for a variable. But right now, we're looking in the global, all of the names that are like, well, just not inside a table. Because really what happens is there's a global table, and every variable is inside of the global table, or else it's inside of a table that's inside the global table, or etc., etc. So, Lua Get Global will look at the global table and ask, hey, can you give me the object paired up with this name? Now, there's, of course, much more flexible ways of doing that. We could do Lua Get Table, and then what we have to do is put that there. But then it says int index. What does index mean? Well, we actually have to just say use the global table. So Lua Global, let's see, Lua index, let's see, I thought it was global table index. I forget the name. If I knew the index of the global table, I could put that here. I know there's one for registry. Seem to have forgotten the global table index. Well, that's something that you can look up. But moving on, the idea here is we put some sort of ID here that is the global index, and then you also have to, before you do that, push the string that is str.cstring. So this is the most basic way of manipulating it. And what I'll do is I'll write comments over here on the right that show you what's in the stack. So first the stack was empty, then we pushed the name on there, then we converted the name into the table that pairs up with that name, and we used the global, we searched inside the global table to find that. There's also a registry table that's sort of hidden to the Lua scripts but available to C++, or it could have been a table that I've stored on the stack. So I could use another index on the stack, put a table in that index, and then reference that table and search inside that table that I made in my Lua script somewhere. But I'm gonna be looking inside the global table in this case. So that's the longer way of doing it. And what we'll end up having is the table that I'm going to handwrite into the Lua scripts, which will contain the correct function. But like I said, there's a shortcut in case of global, is you can do Lua Get Global, and instead of having to have the push string function, we can just go straight to str.cstring, like that. Now, the next thing we're going to need to do is we're going to need to search inside the table. So let me put these comments over here. We just got that table. Now that's the first index in the stack. Now let's go ahead and look inside that table for something that we will pre-decide the name of the function for. So maybe push string s. Let's make the name of the function colors. So now what we should have is two things on the stack, like so. Colors. Next we're going to call Lua Get Table S -2. Now, here's a property of the stack I haven't talked about before. So this has index 1, this has index 2. But the stack can also be indexed backwards. If I use negative numbers, it starts from here. This has index -1, this has index -2. And sometimes it's just better to index from the top instead of from the bottom, because maybe in truth I was actually in the middle of a different Lua operation. Maybe there's actually a ton of stuff here that I don't know about. So I have to not also be aware that I'm not directly allowed to edit this stuff, but I also don't want to accidentally read any of it. So I'm going to just access from the top where I know what's there. And I know the table is 2 from the top, or is not, like, not the negative, it's second one down, so it's -2. If that's true, then when I do get table, what I should get is whatever's paired up with the string's colors inside the table, and that will be a function. So I'll write here function colors, like so. Now I have the function, and all I have to do is call it. Lua call. So now we're seeing the call function again. This is how I can call a function in Lua that's on the stack. So if I say S0, now I want it to return the 4 colors of the color palette. So how does it know what function to call? Actually, it just looks on the stack. Whatever's on the top of the stack is the function it calls. The only time the function it calls is not on top of the stack is if you have arguments. So say I'm calling a Lua function that takes an x and a y value. I would actually have the function and then x and then y. And then when I put right here that there are 2 arguments, it'll first read the 2 arguments off, and then it'll read the function right off of that. So that's how the Lua call function works. If we go back to when we were using Lua call here, load file actually loads a file, compiles it into the bytecode, turns that into a callable function, and then pushes it on the stack, so that when we call the Lua call function right here, the first function on the stack is the script we want to call. So there we go. Lua call calls the colors, and now what happens after we call that? How do we get the returns? Well, the returns actually get pushed on the stack too. Anything that is called with this function gets its returns pushed on the stack. So we've got color 1, color 2, color 3, and color 4. Now all we have to do is go palette to 0 equals let's see, color Lua 2 user data S -4. So -4 will be this number here. If I convert the user data to a color pointer and then dereference it, I will get my color object. And I'll do that for all 3. Palette 1 equals boom color. And of course that'll have to be -3, -2, -1. This will have to be 1, 2, 3. Now finally, like I was saying before, we have one last little issue to deal with, and that's that there could be a lot going on previously. Maybe I was working on some other C++ thing was going on, manipulating the Lua stack, and I just now called this inside of some other Lua manipulation. So what I want to do is make it so the stack looks exactly like it did before I started messing with it, which the first time I messed with it was when I called Get Global. So it needs to be empty when I'm done. And there's a function called Lua Pop, which will pop those off the stack. So now the table should look, or the stack should look like this. Completely empty, just the way it was given to me is how I give it back. That way I'm never causing any damage to other operations.